This video is for section 3.2. Our objectives for this section are to solve problems using systems of equations and use functions to model revenue, cost, and profit and perform a break-even analysis. We're actually going to start this video with homework problem number 12. There's not a very good example of this type of problem in the example part of the textbook, so we're going to do this problem instead. The problem says that there were 180 people at a Civic Club fundraiser. Members paid $4.50 per ticket and non-members paid $8.25 per ticket. Total receipts amounted to $1,222.50. How many members and how many non-members attended the fundraiser? So we have two variables here, and our first step is going to be to identify each. We have the number of members that attended. I'm going to have that be X, and the number of non-members that attended I'm going to have be Y. You could do it the other way around. It doesn't really matter. Now, I'm going to use the information in the problem to write two equations. That's going to give me a system of equations that I can solve using the methods that we talked about in section 3.1. So the first piece of information that I have is that there were 180 people at the fundraiser. So I can write an equation for the total number of people. If I add the number of members plus the number of non-members, in other words, X plus Y, that should equal the total number of people that attended, which is 180. So that's my first equation. The second equation is going to have to do with the total amount of money or the total receipts. So I know that each member paid $4.50 and each non-member paid $8.25. So if I multiply $4.50 times the total number of members who attended, and I multiply $8.25 times the total number of non-members that attended, and I add those two things together, that should give me the total amount of money that I made at my fundraiser, which is that $1,222.50. So that's my second equation. Multiply the total price per ticket times the total number of that ticket that was sold, add the two categories together, and that's the total amount of money that I made. So these are my two equations. This is my system. From here, it's just a matter of solving it. You can use addition or substitution for these. A lot of times you'll have an equation that doesn't have coefficients like we have here, which means that substitution will work, or addition will work just as well. I'm going to show this with substitution. So I'm going to start with the X plus Y equals 180 equation, and I'm going to get the Y by itself, although you could also get the X by itself. You should get the same answer. But I'm going to get Y by itself by moving the X over, and I get Y equals 180 minus X. Now what I need to do with that is plug in to my other equation, which is the 450x plus 825y equals 1,222.50. So I'm going to replace y with 180 minus x. From here, I need to distribute and then solve for x. $8.25 times 180 is 1,485. Make sure you get that minus sign on the 8.25. I need to combine like terms, these two. Adding those together gives me negative 3.75. Subtract 1485 from both sides. And lastly, divide. One thing that you should note is that when you're dealing with these real-world types of problems, like number of people attending, it wouldn't make sense for me to have a negative number for my answer. So I should expect that my answer should be something positive. And when I divide a negative number by a negative number here, I do in fact get a positive number, so that's good. When I divide those, I get x equals 70. Now the last step is to plug in and solve for y. I'm going to plug into the x plus y equals 180 equation because that's going to be easiest. You probably can do this in your head without even plugging into the equation. But if x plus y equals 180 and x equals 70, I can subtract that from 180 to get my value of y, which is 110. So my answer here is that there were 70 members that attended and 110 non-members. So what we're going to look at next is example 2 in the book. This one is kind of similar. It's about your grandmother investing money. She has $50,000 to invest. She wants to invest part of it at 15% interest and the rest of it at 7% interest, and she wants to earn $6,000 per year in income from both of those investments. That means that she wants the amount of interest that she's earning on the investments to be $6,000. So the question is, how much should be placed in each investment? So again, we have two variables here. X, I'm going to set equal to the amount invested in the 15% account, the bonds, and Y equal to the amount invested in the 7% account. So we have two equations again that we want to write and then solve the system. The first equation is our total amount that we have invested. The amount that she wants to invest is $50,000. So if I add the amount in each account, x plus y, that should equal 50,000. Now, the other equation that we can write is going to come from the interest. If we multiply 15% times the amount invested in that account, 7% times the amount invested in that account, add those two amounts together, that's the total amount of interest that my account is going to earn. Now, one key thing here with this problem is that you don't multiply the amount by 15, you have to convert percentages to decimals. So I have to remember that 15% as a decimal is 0.15, 7% as a decimal is 0.07. Move the decimal point 2 places or divide the percentage by 100 to get the decimal. So the total interest earned equation is 0.15x plus 0.07y And the total amount that she wants to earn in interest is $6,000. So those are my two equations. Now I'm going to solve the system. This one I'm going to do using addition just to show a different method. Again, you could use substitution here as well because I have the x and y with no numbers in front. That would be easy enough. So these are my two equations. For addition, I want to multiply the top equation by a number so that one of the variables cancels out. I could multiply by either negative 0.15 and cancel out x, or negative 0.07 and cancel out y. I'm going to choose to go with the negative 0.07. Doesn't really matter. So negative 0.07x minus 0.07y. Everything needs to be multiplied by that 0.07. 50,000 times negative 0.07 is going to be negative 3,500. Then I need to add. I'm going to put leading zeros in here since I want to be consistent with how it looks. So this is going to give me 0.08 x, y's cancel out. 6,000 minus 3,500 is 2,500. And then my last step is to divide on both sides. Again, I expect a positive number for my answer. It wouldn't make sense to have a negative amount of money invested. And so the answer I get here is 31,250. Now again, I need to find the value of y, so I'm going to plug in to the easier equation, the x plus y equals 50,000. Equation is going to be a little bit easier to work with. Subtract 31,250 and I get y equals 18,750. So for my answer, that means I'm investing 31,250. If I go all the way back to the top, x was the amount invested at 15%, and y is the amount invested at 7%. So that's my answer. What you should do next is checkpoint problem number 2 from the book. Once you're done with that, then you can move on to the homework.